The Bismarck is perhaps the most famous battleship in history, often portrayed as an invincible, unsinkable titan of the seas. For decades, the name has conjured images of a fortress of steel cutting through the waves, the pride of the Kriegsmarine and a symbol of German engineering might. The very mention of the ship evokes a sense of awe, even dread, in naval history enthusiasts worldwide. But what if the legend we've been told isn't entirely accurate? What if, beneath the layers of wartime propaganda and the cinematic glory, the technical reality of the Bismarck tells a very different story? A story not of unassailable triumph, but of outdated concepts, inherent compromises, and, ultimately, a design that was flawed from its very inception. To understand the Bismarck, we must first strip away the hype and move past the enthralling chase and the dramatic sinking to conduct a forensic technical deep dive. This isn't about diminishing the bravery of the crew or denying the ship's intimidating presence. Rather, it is a critical, evidence-based examination of naval architecture, engineering philosophy, and the strategic doctrines that shaped its construction. While the ship was massive, its engineering was plagued by inefficient use of displacement and a reliance on World War I-era protective schemes that had already been surpassed by its contemporaries. By dissecting the armor, propulsion, and armament, we can begin to see why this celebrated behemoth was, in technical terms, a deeply compromised warship. The fundamental issue with the Bismarck begins with its origin. It was a 1940s ship built with a 1910s mindset. Following the restrictive years of the Treaty of Versailles, German naval designers lacked the continuous, iterative experience enjoyed by the British, Americans, or Japanese. This design gap forced the engineers at Blohm and Voss to iterate on the last successful design they knew, the World War I-era Baden class. While other nations were moving toward modern, all-or-nothing armor schemes and high-pressure steam plants, Germany stuck with a conservative, incremental approach. The result was a ship that was exceptionally heavy for its actual combat capability, wasting thousands of tons of displacement on redundant or inefficient systems that failed to provide the protection required in the age of long-range aerial and naval gunnery. When enthusiasts talk about the Bismarck, they almost always point to the turtle deck armor arrangement. This system, characterized by a sloped internal deck that angled down to meet the bottom of the main belt, was designed for short-range, horizontal engagements, the kind of knife fight seen at Jutland in 1916. At close range, it was indeed incredibly difficult to penetrate the ship's vitals. However, by 1940, naval combat had evolved. Engagement ranges had opened up significantly, meaning shells arrived at steep, plunging angles. Against these descending shells, the Bismarck's armor was poorly distributed. The upper works and vital communication lines were left exposed, sitting above the main protective deck. Furthermore, the Bismarck's armor was distributed over a wide area rather than concentrated around a central citadel. This resulted in a massive displacement, reaching over 50,000 tons at full load, without providing the same level of protection against heavy-caliber shells as the contemporary American North Carolina class or the British King George V class, both of which were technically smaller ships. Because so much weight was tied up in the old-fashioned turtle deck, the ship's decks remained dangerously thin. This vulnerability was a ticking time bomb. In a long-range duel, a single plunging hit could penetrate straight through to the magazines or the boiler rooms, bypassing the heavy belt armor entirely. The inefficiency didn't stop at the armor plates themselves. It extended to the very layout of the ship's communication and power systems. A modern battleship design typically buries its most sensitive nervous system elements, the fire control cables, secondary power lines, and internal communications, deep within the armored citadel. In the Bismarck, many of these critical links were located above the main armored deck. This meant that even if the ship's hull remained afloat and unsinkable, its ability to fight could be neutralized by relatively light fire. This design flaw would prove catastrophic during its final engagement, where the ship was effectively turned into a floating, helpless target long before it actually sank. Beyond the armor, the Bismarck's machinery and propulsion system represented another significant step backward compared to international standards. Most modern battleships of the era utilized a four-shaft arrangement, which provided better redundancy, balance, and maneuverability. However, the German designers opted for a three-shaft layout. This decision was largely a holdover from older designs and a lack of innovation in turbine arrangement. The three-shaft system created a fundamental vulnerability. The middle shaft was positioned directly along the center line, which restricted the space available for the steering gear and the twin rudders. This cramped arrangement meant the rudders were placed in a V shape, dangerously close to the propellers. In any naval engagement, the stern is a sensitive area, but for the Bismarck, it was a catastrophic failure point waiting to happen. Because the rudders were so exposed and the propellers were so close, a single hit to the stern didn't just damage the steering, it could jam the entire assembly into the screws. This is exactly what happened when a single, relatively light Mark 12 torpedo from a British Swordfish biplane struck the stern. The explosion jammed the port rudder at a 12-degree turn, effectively crippling the ship. In a four-shaft design with more widely spaced rudders, there is a much higher probability that the ship could have continued to steer using differential thrust from its engines. For the Bismarck, the three-shaft layout turned a survivable hit into a death sentence. Furthermore, the steam plants themselves were a source of constant technical headache. Germany utilized ultra-high-pressure steam systems that were theoretically more efficient, but practically a nightmare to maintain. These plants were incredibly complex and prone to frequent breakdowns, requiring a level of precision and constant upkeep that was difficult to maintain during a high-stakes Atlantic sortie. While American and British ships used more robust, reliable medium-pressure systems that could handle the rigors of combat and long-distance steaming, the Bismarck's machinery was fussy. This technical fragility meant that the ship was often operating at less than peak efficiency, further undermining its supposed status as a dominant predator of the seas. The Bismarck's main battery consisted of 8 38-centimeters, 15-inch SK C/34 guns. While these were excellent pieces of artillery with high muzzle velocity and great accuracy, the way they were mounted was once again inefficient. By the late 1930s, most naval powers had moved toward triple or even quadruple turrets. By sticking with twin turrets, the Bismarck required 4 separate barbettes and 4 massive rotating structures. This took up an enormous amount of internal space and added thousands of tons of unnecessary weight to the ship's displacement. A ship of 50,000 tons should have easily carried 9 or even 10 15-inch guns in triple turrets, or perhaps 8 16-inch guns, matching the firepower of the North Carolina or Iowa classes. Instead, the Bismarck had the broadside weight of a ship 15,000 tons lighter. This displacement tax meant the ship was massive and expensive to build, yet it lacked the punch of its contemporaries. This inefficiency extended to the secondary armament as well. The Bismarck utilized a split secondary battery, 15 centimeters guns for surface targets and 10.5 centimeters guns for anti-aircraft defense. This was an incredibly outdated philosophy. The US and UK had already pioneered dual-purpose guns like the American 5-inch/38 caliber, which could engage both ships and planes effectively. By splitting the battery, the Bismarck forced its crew to manage 2 different supply chains of ammunition, 2 different sets of fire control directors, and 2 different types of training, all while taking up more deck space and weight. The fire control system itself, while Zeiss-designed and optically brilliant, was another victim of the ship's poor structural layout. As mentioned earlier, the cables connecting the rangefinders to the plotting rooms were poorly protected. During the final battle, the British heavy cruisers and battleships didn't need to sink the Bismarck with a single blow. They simply shredded the upper works. Within the first 20 minutes of the engagement, the Bismarck's eyes were poked out. The sophisticated optics were useless because the unarmored communication lines had been severed. A ship that cannot see or communicate is not a battleship. It is a very expensive target. This vulnerability highlights the core failure of the Bismarck. It was a collection of high-quality components held together by a low-quality architectural philosophy. The most damning technical indictment of the Bismarck is its staggering inefficiency of displacement. In naval architecture, displacement is the currency of a designer. Every ton must be spent wisely on speed, protection, or firepower. The Bismarck was a financial and resource black hole, displacing over 50,000 tons at full load, making it the largest battleship in the world at the time of its completion. Yet for all that mass, it offered no more combat capability than the British King George V class, which displaced nearly 10,000 tons less. To put this into perspective, the German designers spent 50,000 tons to produce a ship with 8 15-inch guns, while the Americans were finalizing the Iowa class, a ship of similar displacement that carried 9 16-inch guns, moved 6 knots faster, and possessed a vastly superior all-or-nothing armor scheme. His discrepancy exists because German engineering in the 1930s was weight-heavy. Without the weight-saving techniques pioneered by other nations, such as extensive use of welding over riveting or the compacting of machinery, the Bismarck grew bloated. A significant portion of its weight was dedicated to a hull that was unnecessarily beamier than it needed to be, a byproduct of needing a shallow draft to navigate German rivers and the Kiel Canal. While this made the ship a stable gun platform, it increased hydrodynamic drag and required more power to move, further straining the already fussy high-pressure boilers. The Bismarck was essentially a middleweight fighter trying to compete in the heavyweight division simply by wearing a heavier suit of clothes. Beyond the nuts and bolts, the Bismarck was a victim of a flawed strategic doctrine. By 1941, the era of the lone wolf battleship was already over, though the Oberkommando der Marine, OKM, refused to admit it. The Bismarck was designed for commerce raiding in the North Atlantic, a role for which it was spectacularly ill-suited. A ship of its size and complexity requires an enormous logistical tail, frequent refueling, specialized dry docks, and a screen of escorts. By sending a 50,000-ton battleship to hunt merchant tankers, Germany was using a scalpel like a sledgehammer. The ship's fuel consumption was astronomical, and its range was surprisingly limited compared to its American counterparts, which were designed for the vast distances of the Pacific. The technical failure of the Bismarck was cemented by its lack of integrated radar and electronic warfare capabilities. While the ship possessed state-of-the-art optical rangefinders, its radar sets, the FUMO 23, were primitive and fragile. During the Battle of the Denmark Strait, the concussion from the Bismarck's own forward main battery guns actually knocked out its own forward radar set. This forced the ship to rely on its rear radar or its optics, effectively blinding it in the foggy, low-visibility conditions of the North Atlantic. In contrast, the British were already beginning to master cinemetric radar, which allowed them to shadow the Bismarck through the night and rain with impunity. The final hours of the Bismarck were not a glorious last stand of an unsinkable titan, but a mechanical collapse. Once the steering was jammed and the unarmored communications were severed, the ship became a mission kill. It didn't matter that the hull was still floating. The ship's ability to function as a weapon of war had ceased within the first half hour of the final engagement. The British battleships Rodney and King George V closed a point-blank range and systematically dismantled the Bismarck superstructure. The overrated giant was a victim of its own architectural heritage. A ship built to survive a 1916 slugfest find itself helpless in a 1941 combined arms environment. The enduring legend of the Bismarck is a testament to the power of narrative over data. For decades, the ship has been framed as a super ship that required the entire British Royal Navy to stop. While it is true that the British committed significant resources to the hunt, this was a reflection of the Bismarck's potential as a commerce raider rather than its technical superiority. From an engineering standpoint, the ship was a dead end. Following its sinking, the German Navy itself began to realize the limitations of the design. The Tirpitz, the Bismarck's sister ship, spent much of the war as a fleet in being, a strategic threat that rarely ventured into open water, eventually being destroyed not by a rival battleship, but by the very thing the Bismarck's armor was never designed to resist: heavy-capacity, tall-boy bombs delivered from the air. When we look back at the Bismarck with a cold, technical eye, we see a ship that was fundamentally out of its depth. It was a 1940s vessel trapped in the design philosophy of the Great War. Its turtle deck armor, though formidable at close range, left its nervous system exposed to modern long-range fire. Its three-shaft propulsion layout was a structural liability that directly led to its destruction. Its main battery was inefficiently housed, and its secondary armament was a logistical nightmare of split purposes. Most tellingly, it was a 50,000-ton behemoth that brought only 35,000 tons of actual combat value to the table. In a high-stakes game of naval architecture, the Bismarck was a massive overinvestment for a very modest return. To call the Bismarck a failed design is not to say it wasn't dangerous. Any platform carrying 8 15-inch guns is a threat. However, in the context of professional naval engineering, a design fails when it does not maximize the potential of its displacement and resources. By this metric, the Bismarck was an undeniable failure. It was the product of a nation that had been out of the game for too long, relying on nostalgic iterations of old successes rather than the bold innovations of its peers. While the U.S. Navy was developing the Iowa class, and the Royal Navy was perfecting the dual-purpose integration of the King George V, Germany was building a bigger Baden. Comparison graphic: Bismarck silhouette versus Iowa class silhouette. The Bismarck represents the ultimate triumph of aesthetics and propaganda over technical efficiency. It looked like the ultimate warship. It was sleek, massive, and intimidating. But beneath the paint and the propaganda lay a ship that was structurally vulnerable and mechanically outdated. It was a giant, yes, but a giant with a glass jaw and a crippled heart. In the final analysis, the Bismarck was not sunk by a lucky hit to the rudder. It was sunk by the cumulative weight of its own design flaws that were baked into its blueprints years before it ever met the British fleet. Closing image: archival photo of the Bismarck sinking, fading into a modern technical blueprint. Ultimately, the story of the Bismarck serves as a cautionary tale in military history. It reminds us that size is not a substitute for sophistication, and that a legend built on propaganda can never withstand a scrutiny of technical reality. The unsinkable Titan was, in truth, an overrated giant, a magnificent, terrifying, and deeply flawed relic of a bygone era, destined to be outclassed by the very future it tried to dominate. One of the most persistent myths surrounding the Bismarck is that its massive displacement was synonymous with structural durability. In reality, the ship suffered from what naval architects call a poor strength-to-weight ratio. Because the German designers used a combination of older riveting techniques and early-stage electric arc welding, the hull was not as structurally unified as the contemporary American hulls. During its trials, and even during its combat sortie, the Bismarck exhibited significant vibration issues when traveling at high speeds. These vibrations weren't just a nuisance for the crew. They were a technical liability that threatened the alignment of the very fire control systems the ship relied on to fight. Diagram: stress points on the Bismarck's hull during high-speed maneuvers. Furthermore, the ship's internal longitudinal strength was questionable. Modern battleship designs, like the Iowa or the Yamato, utilized a more sophisticated box girder construction to ensure the ship could withstand the immense stresses of its own heavy gun fire and the impact of torpedoes. The Bismarck, however, relied on a more traditional and heavier frame and plate system. This meant that while the ship was heavy, that weight was often dead weight, material that added to the displacement without contributing to the overall structural integrity of the hull. This inefficiency is a recurring theme. The Bismarck was a ship of 50,000 tons that behaved, structurally and tactically, like a ship of 35,000 tons. This weight tax also affected the ship's stability. While the broad beam of the Bismarck made it a stable gun platform in moderate seas, it had a dangerously low reserve of buoyancy. In naval terms, this meant that once the ship started taking on water, it lost its ability to stay upright much faster than designs with a more modern internal subdivision. The many blind spots in its internal compartments, areas that were difficult for damage control teams to reach, meant that once the hull was breached, the flooding was often impossible to contain. The Bismarck wasn't unsinkable. It was simply a very large bucket that, once punctured, had no effective way to stop the flow. If there is one area where the Bismarck's technical failure is most glaring, it is in its anti-aircraft AA suite. As we move into the 1940s, the primary threat to capital ships was shifting from the big guns of rival battleships to the wings of carrier-based aircraft. The Bismarck was tragically ill-equipped for this transition. Its heavy AA battery, the 10.5 centimeters SK C/33 guns, were mounted in high-angle twin turrets that were not triaxially stabilized. This meant that as the ship rolled and pitched in the rough Atlantic swells, the guns struggled to stay on target. The fire control computers for these guns were also designed for much faster, more modern planes and struggled to track the slow-moving, canvas-covered swordfish biplanes that eventually delivered the fatal blow. Footage/image: British swordfish biplanes attacking the Bismarck. Below the heavy AA guns, the situation was even worse. The intermediate 3.7 centimeters Flak 30-38 guns were single-shot, hand-loaded weapons. In an era where the U.S. Navy was installing quad-mounted, fully automatic 40mm Bofors cannons that could put a wall of lead in the air, the German 3.7 centimeters guns were an archaic joke. A crew had to manually load each shell, making the rate of fire abysmally slow. During the torpedo attacks, the Bismarck's AA gunners reported that they simply couldn't track the planes effectively because their equipment was too slow and their sights were obscured by the spray of the ship's own bow wave. This technical inadequacy was a direct result of the German Navy's failure to recognize the importance of the aircraft carrier. While the British and Americans were building their fleets around air defense, the Germans treated AA as an afterthought, a secondary system to be bolted onto a ship designed for a 1916-style surface duel. This blindness to the sky was the ultimate technical hubris. A ship costing millions of Reichsmarks and carrying thousands of men was left defenseless against a handful of obsolete biplanes because its designers refused to believe that a Titan could be brought down by something as flimsy as a string-bag airplane. The final engagement on May 27, 1941, provides the most objective data on the Bismarck's design failure. It is often cited that it took hundreds of shells and several torpedoes to finally sink the ship. Supporters of the Bismarck use this as evidence of its toughness. However, a technical analysis reveals a different truth. The Bismarck was mission-killed within minutes. A mission kill occurs when a ship is still afloat but can no longer perform its duty. Because the Bismarck's vital fire control cables and command centers were located above the armored deck, they were destroyed almost immediately by the initial salvos of the HMS Rodney and HMS King George V. Once the optics were shattered and the communication lines severed, the Bismarck's massive 15-inch guns were reduced to local control. This meant individual turret officers had to aim the guns using only the small, limited-range sights on the turrets themselves. In the smoke and chaos of battle, this was impossible. The Bismarck stopped hitting its targets long before it stopped floating. The distributed armor scheme, which protected the waterline but left the brain of the ship exposed, proved to be a fatal compromise. The ship became a floating iron coffin, its hull intact, but its ability to fight back completely neutralized. Compare this to the all-or-nothing scheme used by the Americans and British. In those designs, everything vital, the guns, the engines, the magazines, and the command wires, was packed into a single, heavily armored citadel. If a shell hit the ship outside that citadel, it might cause a fire or a hole, but the ship could still fight. The Bismarck tried to protect everything and ended up protecting nothing of substance. It was a 50,000-ton monument to a flawed philosophy, proving that in modern naval warfare, the ability to endure is meaningless if you lose the ability to strike back. When we weigh the evidence, the conclusion is inescapable. The Bismarck was an engineering dead end. It was the largest, most expensive, and most famous ship of its time, yet it was technically inferior to almost every contemporary battleship designed by its rivals. It was a ship of seconds, second-rate armor distribution, second-rate propulsion redundancy, and second-rate anti-aircraft defense. Its only first was its sheer size, and even that was a failure of efficiency. The tragedy of the Bismarck is that it was designed to win a war that had already passed. It was a beautiful, terrifying ghost of the Imperial German Navy, resurrected in an age of radar, aircraft carriers, and dual-purpose artillery. While the legend of the unsinkable Titan will likely persist in popular culture, the technical reality is far more sober. The Bismarck was not the pinnacle of naval engineering. It was its most expensive mistake. It remains a powerful reminder that in the face of rapid technological change, clinging to the tried and true is often the fastest way to obsolescence. The giant didn't just fall, it was designed to fail.